Hello students, welcome to the next lecture on the IIT JAM Mathematical Statistics. In this lecture, I will cover all those PY questions related to the random variable from the year 2013 to 2023. Myself Dr. Harish Garg. You can simply follow my YouTube channel. Here the channel name is my Dr. Harish Garg, and you can find the playlist of the IIT JAM. You can see the complete previous year solutions of the IIT JAM Mathematical Statistics is a question number wise, as well as the complete topics related to JAM 2021, 2022, 2020 and many more available in this playlist. You can simply follow this. You can subscribe my channel. So as I told you, I will cover the 25 plus question in this random variable. All are with the help of the shortcut tricks. So since the random variable topic is a very vast topic in this IIT JAM Mathematics, so I will divide into the 6 subtopics such as random variable, CDF, expected mean, movement generating functions, and here. In this lecture, I will cover all those questions related to the random variable. After this lecture, I will cover about the CDF, expected mean, and many more. Make sure before you can learn about the shortcut tricks or the random variable, you must remember about the probability mass functions or the density function of some standard distributions. I hope you must know about what is the standard distributions like of these. These are my discrete distributions, Bernoulli, binomial, Poisson, and these are my continuous. In this binomial, you must know about its the probability mass function, you must know about the mean, you must know about the variance. Similarly for this continuous distribution. Whenever we are talking about the continuous distribution, you must remember it's the CDF also. Fine, so that will be the easy for you. For the sake of simplicity, I can mention you here, like for the binomial distribution, the mean is NP, variance is NPQ. If you consider n is equal to 1, then you can move to the Bernoulli. While on the Poisson distribution, the mean and variances are always equal. While the geometric distribution is my here, x start from the 1, 2, 3 and so on. If some student will consider x is my 0, 1, 2, then the mean will be my q over p instead of the 1 over p. So that's the only difference you can see here. These are my discrete distribution. However, if you work on the continuous distribution, then the uniform distribution is my here. What is the PDF and what is the CDF of the uniform distribution? X minus a over b minus a. What is the CDF of the exponential distribution? This is 1 minus e raised to power lambda x. And once you know the gamma distribution, the mean is the parameter corresponding. I can return this number as gamma distribution with the parameter alpha and beta. Remember, alpha is the power of the x and beta is the exponential part. Based on this, I can solve each question within a 15-second trick. Let's see this one. A continuous random variable x. Remember that you have to read the statement very carefully. A continuous random variable x. Which continuous random variable? Is it given? Is it a uniform? Is it exponential? Is it a normal? It is not given to you. Fine. So what is that? This capital phi is my CDF. Fine. This is my PDF. Fine. Now, how you can solve that? Because if nothing is given to you, you can simply assume x is my uniform distribution with the parameter 0, 1. Fine. Then I can simply choose phi of x. Phi of x from here is my 1 over 1. CDF, I can assume this quantity as x minus 0 over b minus a. So what is the PDF of this? So f of x will be my 2 into 1 into x. That is my 2x over the domain 0 to 1. Now you can see about the last option. Firstly, x is greater than equal to 0. Because it's a continuous, so it's a 0 to 1, 2x. So what is the right answer of this? It's a 1. But he said less than 0.25. Look at the last option, C option. If it is a less than equal to 0, so clearly say it is my 0. But he said greater than 0.5. Remember, this is the one particular example I have taken. Your target always to discard them. What is the mean of this? So mean is my x into fx over the domain 0 to 1. So 2 is common, x square is my x cube over 3, 0 to 1. So what is the right answer of this? 2 over 3, but he said less than 0. So this option is cancelled. Only option A, which is left behind, is the right answer of the problem. A circle is constructed which follows the uniform distribution over the 0, 1. So can you find the PDF of this? PDF is 1 over B minus A. Then find the probability that area of the circle is less than 1. So what is that? It is probability R is less than of 1 over root pi. Now since it is a continuous random variable, fine. So you can always write in terms of the CDF. So what is the CDF of this R? R minus lower limit divided by upper minus his. So what is that? I can return this is CDF of 1 by root pi. Remember that because this is the continuous random variable, so you have to write probability x less than of the small x, which is same as of x less than or equal to x. So what is the right answer of this? I can substitute here. It is 1 over root pi is the correct answer of this problem. Always remember the PDF and the CDF. You can solve the question within a 15-second shortcut tricks. Look at this one. Now in this case your target is to find the probability. So firstly you can write this. I can express this value as minus 1 plus 1 to here. Then it's a minus half to plus 1. Then plus 1 to 2. What is the value of the minus 1 2 of this is 1 by 4 and it is 1 by 4 x square. So can you solve this integration? So it is 1 plus 1 over 2 minus 1 over 4 is outside and it is 1 over x, because what is the integration of this? It is x raised to power minus 1 over minus 1. So can you solve this integration? It's a 3 over 2. So it's a 3 over 8 minus 1 over 4 half minus 1. So half minus 1 is minus half. So it is a plus 1 over 8. So 4 over 8 is a 1 over 2 is the right answer of this problem. You can see how many seconds you are needed to solve this problem. Again, your target is to find the probability. Firstly, you have to express this. It's a half to 1 and then 1 to 2. So what is the value of this? It's a x cube and this is 3 over x raised to power 5. So what is the answer of this? It's a 1 over 4 x power 4 from half to 1 and it is minus 3 over 4 x raised to power 4. Fine, because you all know what is the integration of this. It is x raised to power minus 4 over minus 4. Now I can substitute this value. It is 1 over 4, 1 minus 16 minus 3 over 4 and it's a 1 over 16 minus 1. So I can see it's a 1 over 4 and it's a minus minus plus 3 over 4. Fine. I can make 1 over 16 as a common. So it is a minus 1 over 4 and it is minus 3 over 4. So what is the right answer of this? It's a 1. It is my minus 1. So what is the right answer of this? 15 over 16 is my right answer of the problem. Look at this another one. Your target is to find this value. Firstly, you can express this number. What is the probability at x is equal to 0? So if I substitute x is 0, this is my 0. So answer will be k. Fine. Now how you can find the value of k? So we all know it's a sum should be 1. But in this case, we needed this value. Fine. So can I find the values of this? When x is my here, when it's a minus 2, it's my 2 plus 1, 3. 3 square is 9k. When it is minus 1, it's a 2. 2 square is 4. When it's a 0, it's my 1k. It's a 2, it's a 4k, it's a 9k is my 1. So can you find the sum of this? 9, 13, 14. 14k plus 13k is my 1. So what is the answer of the k? K is my 1 by 27 is the right answer of this problem. You can see how many seconds you are needed to solve this, a very fraction of second. You can simply scan and join my WhatsApp group if you want. It's a very beautiful and we can discuss more in my group also. Okay, what is given to you? X follows my uniform distribution over the domain pi by 6 to pi over 2. Now it's a continuous distribution. Can you find the PDF? So it is a 1 over b minus a. So pi over 2 minus pi over 6. So 6 is the LCM. 3 minus, so it's a 2 pi over 2. So that's a pi over 3. And again, I can write in terms of the CDF also. So x minus lower limit divided by the difference, it's a pi over 3. Now your target is to find the probability of sin x is less than of cos x. So or I can return this number is tan x is less than of the 1. So in which quadrant they are talking about that? They are talking about the first quadrant. So what is the value of the first quadrant when x will be here? It is less than of pi by 4. Fine. So I can return this number as CDF of pi by 4. I can substitute here. So what is that? It's a pi over 4 minus pi over 6 divided by pi over 3. So 12 is the LCM. 3 minus 2. So pi over 4 divided by pi over 3. 1 over 4 is the right answer of this problem. Always, whenever you have the uniform distribution, always write in the terms of the CDF. You will get your answer within a fraction of a second. Okay, let x and y are my discrete distribution, and look at that, what is given to you? This is my conditional probability. Fine. So which things come in your mind when you look about the conditional probability? Do you remember any of the result? Always apply the Bayes theorem. Fine. Always apply the Bayes theorem. So what is given to you? X is my 0. Fine. This is the one case. Second case is x is equal to 1. So what is the probability of the x is equal to 0? What is the probability of the x is equal to 1? X is equal to 0 is my 3 over 4 and this is my 1 over 4. Remember that. Always remember, if the sum of this is my 1, then only you can apply the Bayes theorem. Fine. Now in this case is my 1, so you can apply the Bayes theorem. Now what is that? Now there are two cases. Either y is 0, this is the first case, or y is equal to 1. Fine. Similarly, you have this case also, y is equal to 0 or y is equal to 1. Now since y has only the two elements, now you can see when x is 0, y is equal to 0, the answer is 7 over 8. So since y has only the two elements, so this pair is my 1 over 8. X is equal to 1, y is equal to 1, so this is my 3 over 4 and this will be my 1 over 4. Now your target is to find the probability of y is equal to 1. How many ways you have, you can reach about this? This is a 1, this is a 2. So it means you can go from this side and this case. So what is the right answer of this? 3 over 32 and this into this plus 3 over 16. So 32 is my LCM. 3 plus 6, that is a 9 over 32. What is the probability of y is equal to 0? Again, you can see from the table, y is equal to 0 is at here and y is equal to 0 at here. So you can go from this to this. This is my 21 over 28 plus 1 over 4 into 1 over, sorry, it's a 32, 7, 3, 21 and 28, 32 and it's a 1 over 16. So again 16 will be the LCM. Fine. And it will be 2, so it's a 23. Now I can substitute this value here. 3 times of this, 27 over 22 minus y of 0, 23 over 60. Fine. Now you can, is it true? 7, 3, 21 is a 21 over 32 and it is my 23. So can you take the LCM of this? So its LCM is 32. Fine. Then it is my 32. Now you can take this. It's a 4 over 32. That is 1 over 8 is my right answer of this problem. Always remember, you can apply the Bayes theorem whenever you find the conditional probability. Make sure whatever you have to take the starting point, that should be the 1. Otherwise you can't apply the Bayes theorem. Okay, look at this another one. X is a random variable. So clearly say it is my continuous random variable because x is my greater than or equal to 0. Can you remember that which distribution it follows? Yes, it is a gamma distribution. The first parameter is corresponding to the x, that is my p. Second parameter is corresponding to my here. Then you know what is the mean of this. As I told you earlier, the mean is my p over alpha, variance is my p over alpha square. Now you can see there are the two methods. The first method is very easy. Assume that this is the option. So if I take p is my 2, p is my 20, alpha is my 2. If I substitute here, can you get as a 20? No. 20 over 2 is not equal to 20. So this option is cancelled out. You can see about here, p over alpha, 40 over 2. 40 over 2 is my 20. It's satisfied. Similarly for the variance, p over alpha square, it is my 10. Again satisfied. So this is the right answer. You can check about here. This is my p because the second pair is my p. Alpha is my first pair. So what is that? P over alpha. What is my p over alpha is 10, but we need a 20. So this option is cancelled out. This is my p. This is my alpha. So p over alpha will be my 20 over 4 is 5, but we need a 20. So the right answer is my B is my right answer. There is one more method. Second method is how you can do. You can look about the option. You can see about the statement. Mean is my 20. That means p over alpha is my 20. Variance is my 10. So what you can do? You can divide them. If you divide them, alpha will be my 2. Once alpha will be my 2, so p will be my 40. So that's on your choice whether you want to choose the option and discard them, or you can simplify it. So the right answer is B is the correct option. Okay, look at continuous random variable. Again, because x is greater than 0, continuous, which follows that. Again, is a gamma distribution with the first parameter r and second is my lambda. Mean is given to you as a 2. So what is the meaning of that? In this case, what is the mean is? First parameter over this, variance is r over lambda square. So given that mean is my 2 and variance is also my 2. So from these two, if you divide them, what is the value of this? Lambda should be 1. If I substitute lambda 1, r is my 2. So therefore, what is my PDF? Lambda is my 1. So this is my 1. 2 minus 1, 1 factorial is 1. This is my x, e raised to power minus x. Now you can find this value. Lower limit is my 0. So 0 to 1, x e raised to power minus x. So can you integrate them? It's a x plus 1 e raised to power minus x. Always remember, I told you the shortcut tricks. Whenever it's a one term is my polynomial, fine, you can write the two terms. You can find the derivative of this until you will get as a 0. And for this case, you can integrate them. You can integrate them always. Fine. Minus plus 1. Then you can multiply this. You can multiply them. Plus minus sign. So you can see what is the answer is minus x e raised to power minus x and minus e raised to power minus. So that is the integration of this part. You can see I can take of this. Fine. So this is my 0 to 1. So if I minus, I can take as outside. If I take 1, it's e raised to power minus. If I take 0, it's a 1 and of this. So what is the right answer of this? 1 minus 2 over e. So you can substitute e is my 2.718. Okay. So you can see 0.718 divided by 2.718. You can do your calculator. You can get your answer as here. Remember, this is a very simple shortcut tricks for you. For example, if you want to find, say, x square e raised to power x, how you can do? You can write x square here, e raised to power x. You can use the derivative of the polynomial until you will get 0 and integration of this part, e raised to power x, e raised to power x, e raised to power x. Multiply this, multiply this, multiply this with the sign plus minus plus. So what is the answer of this? X square e raised to power x minus 2x e raised to power x plus 2 e raised to power x. That is quite easy for you to solve the problem. Similarly, if you have, say, x into sin x, again you can use the same rule. You can write x and sin x separately. It is a polynomial. you can use the derivative and you can use the integration of this minus cos x minus sin x. Multiply them with the plus minus. So it is a minus x cos x minus minus plus sin x is the integration of this. Anyhow, now we can move ahead. Okay, let x be the continuous random variable. Then what is the value of the e of x square? I think it's quite easy because it can be written as x square over 2 plus x square, fine, into dx. And what is the range is minus infinity to plus infinity. How you can solve? Whenever it's x square, how you can do that? I can substitute x is my root 2 tan of y, fine. So what is my dx? The dx will be my root 2 secant square y. So I can substitute here x square, it's a 2 tan square y divided by x square. 2 will be the common, so 2 raised to power 3 by 2 is the common. It will be the 1 plus tan square, it's a secant square. Secant square of 3 by 2, it's a secant cube, into root 2 secant square y dy. What is the limit of y? When x is minus infinity, so y is my minus pi over 2 to plus pi over 2. So you can see it's a root 2, it's a 2 raised to power 3 by 2 and it will be cancelled out. Secant square, it will be cancelled out. I can written it's a sin square over cos y because 1 secant is cancelled out, fine. So how you can solve that? It's a 1 minus cos square y over cos y, fine. So it is a secant y minus cos y. What is the integration of the secant y? Log of secant y plus tan y, and it will be my sine of y from minus pi by 2 to plus pi by 2. Now clearly say when you substitute pi by 2, what is the tan pi by 2? It's a infinity, and ln of infinity is my here. So that means the answer is does not exist is my right answer of this problem, because sin pi by 2 is 1, minus sin pi by 2 is again 1, but tan of infinity is not defined. So you can see D is my correct answer of this problem. Look at this one. So this is my discrete. So whenever you have the discrete, you can write in the table. N is my minus 2, minus 1, 0, 1 and 2. What is the probability? When this is minus of 2, this is my C. When it is a minus 1, it is my twice of C. This is my D. This is my Cn, and this is my 2C. So your required target is to find the expected value of the x. So what is the expected value of the x? N into Pn, fine. So it's a minus of 2C plus 0 plus C plus 4 of C. So this will be cancelled. So it is my C. So your required target is to find the value of C. Also given that probability mod of x is less than equal to, so these are the three cases, fine. It will be 3 by 4. So it means 3C plus D is my 3 over 4. And second case, we all know the sum of the probability will be 1. So it's 4, 6D should be 1. So can you solve them? You can subtract them. It will be minus of 3C. It is minus 1 over 4. So C is my 1 over 12. And my required target is to find only C. So the mean will be my C. That is a 1 over 12 is the right answer. There is no need to find the value of the D because we don't need them. Okay, look at this another one. X is a random variable having the binomial distribution P, and which of the following is here. Okay, first of all, always remember this value is not equal to 1 over e of 1 plus x, fine. Although if it is written like here, then it is fine. Then you can written this number as e of x plus e of x. But whenever you have here, you have to apply the Jensen inequality. But there is no need to find that because they are talking about the exact value. Okay, now the answers are depending upon the n and p. So I can choose the value of the n as per my own convenience. So n is greater than 1. I can choose n is my 2. Probability can be any number between them. So I can choose p is my half. If I choose p is equal to half, then what is the answer of this? 1 minus half raised to power 3 divided by 3 into here. This answer will be 1 minus half of 3 into 1 by 2. You can see both the options are same. So there is no, it means we can change the value of the p. Fine, we need a distinct value. So p is my 1 by 3. So then, or you can choose any other number. So if I choose 1 over 3, then it will be 1 minus 2 over 3 raised to power 3, n plus 3 into 3 is my 1. This number will be 1 minus 1 over 3 raised to power 3 into 2 by 3. So it's a 2, it's a different. 1 minus, it's a 2 over 3 raised to power 3 divided by 2 into 2 by 3. So it's a 4 over 3. This is 1 minus 1 over 3 raised to power 2 and 3 into is my 1. Now all the options are different. Now you can see about that. What is the binomial distribution? Now you can see I can open this value. What is that? I can return this is a summation of 1 plus x, n is my c, x probability is my half 1 by 3, q is my 2 over 3 raised to power 2 minus x. What is the value of the x's? X varies from 0 to 2. Now you can see when x is 0, it is my 1, 2c0 is my 1, x is 0, it's my 1, and it is my 2 over 3 raised to power 2, plus when x is equal to 1, it is my 1 over 2, when x is equal to 1, 2c1 is my 2, it is my 1 over 3, it is my 2 over 3, plus when x is equal to 2, it is my 1 over 3, 2c2 is my 1, it is 1 over 3 raised to power 2, and it is my 1. Now you can see 4 over 9 plus 2 over 9 plus 1 over 27. So what is that? It's a 6 over 9 plus 1 over 27. So 27 is my LCM. So 18 plus 19 by 27 is the right answer. Now you can simplify it. You can see it is my 1 over 1 minus 9. It is not option. You can see it's a 8 over 27. It's a 3 over 4. So it's a 6 over, it's a 2 over 9. But it's a 19 over 27. This option is also cancelled. Look about this one. 1 minus 1 over 27 over 2. So 26 over 54. Again, it is not, this option is cancelled. I can check about here. It's a 8 over 27. You can see 19 over 27. A is my right answer. So otherwise, if you don't take this, then you have to open this NCX. Is a very complicated problem. Okay, so whenever you have the unknown terms, always think about particular value. You can choose n is equal to 3. You can choose n is equal to 4. That's on your choice. But the smallest one you can choose it so that you will get your right answer in a simple manner. You may choose p is equal to 0.4. You may choose p, any number between them. If I choose p is equal to half, then I saw that these two answers are same. Then you are unable to distinguish between them. Okay, now you can see about this. What is that? X is my Poisson distribution. Okay, the mean of x plus 1 factorial. Again, it's a simple. You can open this value because x follows the Poisson distribution, e raised to power minus lambda. So mean is my here. This lambda raised to power x over x factorial. X varies from 0 to infinity. So x plus 1 factorial, I can cancel it. It will be only my x plus 1. E raised to power minus half, I can take it as a outside. Fine. And it will be half of x. Fine. 0 to infinity. So now I think it's over. I can open this bracket, x into half of x plus summation of half of x from 0 to infinity. Fine. Now what is that? E raised to power minus half. What is that? This is nothing but my GP. So what is the sum of the GP series? a over 1 minus r of this. Fine. Do you remember that what is the distribution of this? Can you find, can I say this distribution is my geometric distribution? I can return this number as of this. Fine. So that means this is my geometric distribution, or I can say it's a minus of half. This, it will be my half minus 1 into 2. Fine. So once it's a geometric distribution, what is the value of, how you can find this? What is the mean of the geometric distribution? The mean of the geometric distribution is 1 over p. Fine. If x start from the 1, so clearly say if I x substitute 0, then there is no problem. I can substitute x is, instead of the 0 I can take n as a 1. So the mean is 1 over here. So it will be 2. So 2 plus 2, 4. 4 e raised to power minus half. Is there any answer? Yes. This is e raised to power minus half. So B is my right answer of the problem. There is one more method. Instead of, if you don't remember, this is the GP series or this is the geometric distribution, I can take, say this is my a, x into half of x. Fine. So what is that? If I open this, 0 is then it's a half, or I can simply take this as a lambda. I have to write again and again. So if I start from the 0 to infinity, so it's a 1 plus 2 into lambda square, 3 into lambda cube, 4 into lambda 4, and so on. So do you remember that? Yes, this is the arithmetic geometric series. So I can multiply this by common ratio. Common ratio is lambda on the both side. It is lambda square, then 2 lambda cube, then 3 lambda 4, and so on. If I subtract them, it will be my here. So it's a 1 plus lambda square, cube, and so on. So what is that? It's a GP series over here. So this, so what is the lambda? Is my half. If I substitute half of a, this is half over half is my 1. Again you can see a is my 2 that I have written here. But since you are the statistics student, you must know about that this is a geometric distribution, and when you multiply this by x, what does it mean? This is the mean of geometric distribution. Okay, look at this one. X is a distribution function with the probability mass function here. Then you have to find the variance of this. I think it's a very simple. Which things come in your mind when you look about this term? Remember, this is the recurrence relation. That is just like, say, mode and the median. Fine. If you remember that, what is the distribution of this? Which distribution of here? Then you must know about that. This is the Poisson distribution. Fine. Otherwise, if you don't remember this, can you think about any of the discrete, because x varies from 0, 1 to here. It is a discrete distribution. Do you remember any of the discrete distribution which involve x plus 1 or x? That is my Poisson distribution. So if I simply choose, this is my minus lambda over x factorial. If I substitute here, you can see this lambda raised to power x plus 1 divided by x plus 1 factorial. This is ln 3 over x plus 1 e raised to power minus this over x factorial. Now clearly say x plus 1 and this is x plus 1 cancel. E raised to power minus lambda will be cancelled. Lambda raised to power x will be cancelled. So lambda is my here. So once you consider the Poisson distribution, what is the mean and the variance? Both are same, and both are same to be lambda. So the right answer is A is my correct answer. Look at this another one. A continuous random variable here, which of the following statement is my false statement? Okay, this is the double exponential. Fine. And clearly say, okay, the domain is my here. If you look about the first option, x mod x, how you can solve this? It's a minus infinity to plus infinity, x mod x into f of x. Fine. Now your target is to check whether it's a 0 or not. What is that? How you solve that? You always remember if you have the limit from minus a to a, f of x is 0 when f is your odd function. Fine. So your target is to check whether this is an odd function or not. There is no need to solve them. You can see because of this mod function, this is my even, this is the mod function, this is my even, this is the x, so it is my odd function. So what is the answer of this? It's a 0. So but he said false statement, so the first one is my correct statement. Look at the second option. I can again written as this x mod x square into fx. Fine. Now look at that. This is my even, this is my even, this is my odd, so the answer will be 0. So this is also my correct statement. Look at the third option, minus infinity to infinity mod x sine x over mod x into half e raised to power minus mod x. This is my even function, this is my even function. X over mod x, we all know this value is either plus 1 or minus 1. So that means this is my odd function, because either consider the plus x or minus x. So the even and odd, so its answer is odd. So this complete is my odd function. So answer is 0. It is also a correct statement. So only left is my here. How? You can see that if I write here, this is x square over mod x into half e raised to power minus x. So this is my even function. Because of this x square, this is also my even function. Mod x is also even function. So once they are the even function, this value will not be 0. Fine. Although it will be the twice of this, so it will not be the 0. So this is my false statement. Fine. Okay, apart from them, if I ask you one more apart from this, if I say the x cube of sine x over mod x, fine, into fx. So this is my even function, x cube is my odd function, this is my odd function, fine. But if you look at the product of the odd and odd, this is even function, so this value is also not 0. So that's where you can simply solve that. Okay, y is my uniform distribution over 0, 10. So can you find the PDF of the y? 1 over 10. Once is the PDF, you can find the CDF also. It's a x, sorry, it's a y minus 0 over 10. Then your target is to find the probability of the y which is greater than of 0.5. So it means your target, find the PDF of y. Fine. So it means you are using the transformation. What is the y? Y is my x minus mod of x. How you can find the transformation? If I consider this is nothing but my here dx over dy. Now always look about that. What is that? This is a constant number. Whatever the value of x varies from the 0 to 10, 0, 1, 1, 2, its values are either 0, 1, 2, it's a constant. So what is the dx over dy? So that means it's a linear function. Fine, it is just like say x minus a, it's a linear function. So once it's a linear function, what does it mean? The PDF is same. So what does it mean? Y has the PDF also 0, 10. Sorry, this is the x. This is the x. So it's a PDF of the x, it's a CDF of the x. Fine. So y has the same PDF. So what does it means? Can I write these terms? Can I write this quantity in terms of here? Y is less than 1 by 4. So what is that? It's a 1 minus CDF of 1 by 4. So I can substitute here CDF of 1 by 4. So 1 minus 1 over 4 over 10. So 1 minus 1 over 40. So what is the right answer of this? 39 divided by 40 is my right answer of this problem. Fine. This is a CDF of 0 to 10. So you can see the 39 over 40, whatever is the, you can write them into the decimal places. you will get your right answer of the problem. Okay, look at this next one. Consider the random variable again. I can open this summation 1 over 1 plus x into e raised to power minus lambda, lambda raised to power x over x factorial, while x varies from 0 to infinity. Fine. Then which of the following is my correct state? So x plus 1, and here e raised to power minus 2 I can take is outside. So 2 raised to power x over x plus 1 factorial. Fine. Now there is no need to solve. Look at that, any of the series which is look like say factorial, e raised to power x 1 plus x over 1 factorial, x square over 2 factorial, and so on. So you can see, if I open this bracket, if I start from the 0, it is my 2 over 1 factorial, then 2 square over 2 factorial. If I take x is equal to 0, it's here, then I can take, sorry, x is equal to 0, it's a 2 raised to power 0, x is equal to 1, here x is my 2, then it is my 3 factorial, and so on. Fine. Now you can see I got as a x 1 factorial, but I need a 1 also. So I can add plus 1, I can subtract minus 1. Fine. Now what is the meaning of that? Can you get the expression of this? This is my e raised to power minus of 2. This is my 1. Okay, there is already a 1 here. There is no need to write this. I can simplify. This is 1. It's a 2 over 2 factorial. I can written as a 1 factorial. It's a 4. I can say 2 over 2 factorial. After that, it's a 2 raised to power 3 over 4 factorial. 1 is a 8 over 24. So 1 over 3. 1 over 3 I can written as 2 over 6. So 2 over 3 factorial, and so on. So what is that? This is my, is it exponential series? It is look like, say here, what is the x? X is my, no, x is not a 2. X is not a 2. Okay, just wait. I can simplify it again. E raised to power minus 2. Firstly, I can substitute x is 0. This is my e raised to power x. Okay, I can see here. If it is a x, okay, what is that? It is journal is x raised to power n over n factorial. So what I can do, I can simply add plus 1 and 2 raised to power minus 1 here. Fine. Now you can see this is the same term of this. Is it true? Yes. So I can take 2 raised to power minus 1 here. So then the remaining term will be 2 of x plus 1 over x plus 1 factorial. Now you can open this term. What is that? Half of e square is outside. When I take 0, it's a 2 over 1 factorial. When I take 1, it is my 2 square divided by 2 factorial, and 2 raised to power 3 over 3 factorial, and so on. Fine. Now you can compare this one. 2 over 1 factorial, 2 square over 2 factorial. So only I needed to, I can add plus 1, subtract minus 1. What is that series? This is e raised to power x minus 1. So now you can open this half 1 minus 1 over e square is the right answer. Half 1 minus e raised to power minus 2 is the right answer. Just try to rearrange the terms. Okay, x is a continuous random variable, probability, then expected value of the x. Domain is minus infinity to infinity, x, e raised to power minus x, 1 plus e raised to power x whole square. Now again minus infinity to infinity, this is my odd term. I have to check what is that, whether it's a odd or even. How you can check the even and odd? I can replace x to be the minus x and see whether they are the same term or not. You can see it is 1 over e raised to power x. I can take the LCM. This is e raised to power x whole square. So what is that? 1 upside, so x over 1 plus ex, same term. So this is my even function. Once is a even, this is odd. If you multiply them, it will be 0, because this is a complete is my odd, and the terms is minus infinity to plus infinity is my odd, say 0. So this option is cancelled, this is cancelled. Now probability of x greater than 1, so that means 1 to infinity e raised to power x 1 plus e raised to power x whole square. Fine. So I think that's a very simple. If you simply take 1 plus e raised to power x is my y, so what is that? The numerator is dy over y square. It is minus 1 over y. What is the limit? When x is equal to 1, so it will be 1 plus e. When x is equal to infinity, it is my infinity. So when I substitute infinity, 1 over infinity, 1 over here. So it's 0, and outside this is minus, 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 plus 1 over this is the here. So this is the right option. This option is cancelled. D is my correct answer. Okay, you can see here your target is to find the expected value of the x. So that means x into fx. Fine. Domain is my 0 to 3. So it is ax cube plus bx. So what is that? A over 4 x4 plus b over 2 x square over the domain 0 to 3. So what is that? 3 raised to power 4. It's, I can written as 3 raised to power 4 over 4 into a plus 9b over 2 minus 0. So it means now the only target is to have to find the value of the a and b. Fine. So first case is, we all know the integration should be 1. Fine. So what is the integration of this is a over 3 x cube plus bx over the domain 0 to 3. So what is that? It's at 27, 9a plus 3b is equal to 1. Second case, probability of this is my here. So 2 to 3 ax square plus b is my 2 over 3. So what is that? A over 3 x cube plus bx from 2 to 3. So what is that? It's at 27 over 3, 9a plus 3b minus 8 over 3a and minus 2b is equal to 1. So I can say it's at 27 minus it's a 27 minus 8, so it's a 19 over 3 a plus b is my 1. Fine. Is it clear? Now what you can do, I can simply take the LCM. 19a plus 3b is equal to 3. So you have the two equations. I can subtract them. You can see 3a and 3b cancel. So 10a is equal to 2. A is my 1 over 5. Is it fine? So no, sorry, it's a 2 over 3. It's not a 1. It's a 2 over 3. It's a 2 over 3. So if I multiply, it's a 2. So it's a 1. So a will be my 1 over 10. Fine. So what is the b? If I substitute here, what is the my b is my 1 over 20. So substitute here, it's a 9 into 9 over 4 into a. A is my 1 over 10 plus 9 over 2 into 20. So you can see 40 is the LCM. It's a 80 plus 9 over 40. So what is that? 90 over 40 is the right answer of this problem. 81. Is it 9? 81 is a 9b. What is the b is my 1 over 20. Fine. So is it correct option? It is 80 is a 981 plus what is the, it's a bx x square by 2. It's a 9 over 2. So yes, it's a 9 over 4 is my right answer. Okay, you can see about here, my target is to find this value. Firstly, you can try to solve this problem. This is the intersection x greater than 5 x greater than 5. So what is that? The numerator portion will be of this and denominator will be here. Now since they are my discrete problem, okay, I think it's a simple. I can factorize them, n minus 1, and here it is my 1, it is my minus 1. Fine. Or you can say it's a k times 1 over n minus 1 and 1 over this. Fine. Now you can see this will be 17 to infinity and it will be 5 to infinity of this expression. Now what is the meaning of that? Because you can see if I add them, if I use, okay, I can simply take the value at x is equal to a, which is summation of a to infinity. Fine. N minus 1. Clear? So what will happen? K I can take as the outside. First value is a minus 1 minus 1 over a. After that a plus 1, because they are the discrete number. So 1 over a plus 1 and so on. Fine. So last term is infinity. So you can see all the terms are cancelled. Only term is k over a minus 1. So what is the right answer of this? A is my 17 and a is my 5. So what is the right answer of this? 5 over 16 is my right answer of the problem. Look at this another one. Your target is to e of x square. So I can break them, x square into ax square and 1 to infinity x square into bx raised to power minus 4. So what is that? ax4. So a over 5. Fine. Because it's a x power 5 over 5 from 0 to 1 and it is x raised to power minus 2. So it will be minus 2 plus 1 over minus 2 plus 1. So it will be b times minus 1 over x from 1 to infinity. So a over 5, infinity will be here, plus b. Now your target is to find the a and b. What is the expected value of the x means? A into x plus b into x raised to power minus 3. Fine. This is given as a 1. So what is that? It's a over 4. This is my minus 2, b over minus 2 x square 1 to infinity. So what is that? It's a over 4 plus b over 2 is my 1. Second equation I can integrate this. It should be 1. Fine. So it's a over 3 plus, what is the integration of this? B over minus 3, 1 over x is 1. So a over 3 plus b over 3 is my 1. So from here I can say a plus b is my 3. From here I can say a plus 2b is equal to 4. So I can solve them, I can subtract them, b will be my 1. Once b will be my 1, a is my 2. So I can substitute here 2 over 5 plus 1. So 1.4 is the right answer of this problem. You can see it's a very simple, you can solve them in a simple plus minus calculations are there. Okay, look at the last question. Your target is to find this expression. So half to 1 and 1 to 3 over 2. 4x raised to power k x minus x square over 2. So what is the integration of this? 4 over k plus 1, 1 minus half of k plus 1, fine, plus the integration of this x square by 2 minus x 3 over 6 from 3 by 2 to 1. So it means I need a value of the k firstly. So how you can solve the k? Integration should be 1. So it is 4 over k plus 1 over the 0 1 plus x square over 2 minus x cube over 3 over 1 to 2 is a 1. So I can substitute it. 1 will be 1. So 4 over k plus 1. It is my 4 over 2 8 over 3 minus 1 over 2, 1 over 3. Sorry, x cube over 2 is a 6. So it's a 6 and it's a 6 is a 1. So what is that? 4 over k plus 1. So 4 over 2 minus 1 over 2 is a 3 over 2 minus 7 over 6 is equal to 1. So what is that? 4 over k plus 1. 6 is the LCM. So it will be 9 minus 7 is a 2 over 6. So 2 over 6 and 1 minus. So it's a 4 over 6. Fine. So what is the value of the k? K is my 5. So once you know the k is 5, I can substitute here. So 4 over 5, 1 minus 2 raised to power 6 plus it's a 9 over 4, 8 minus 27 over 8 into 6 minus, I can substitute a lower limit, minus minus plus 6. Fine. Now you can solve this calculation. What is that? I can make them as a 8, 4 over 8. So it's a 5 over 8. I can make 1 over 6 as a common. It is 1 minus 27 over 8. So what is the right answer of this? Is a minus 19 over 8 into 6. Minus 19 over 8 into 6. Fine. I can take 1 over 8 as a common. So it's a 5 minus 19 over 6. So 30 minus 19 is a 11. 11 over 6. So it will be, this value will be my 11 over 6. 1 over 8 into 11 over 6. This value will be 64. It's a 63 over 64. 4 over 5. Fine. Now you can do the calculation. So 1 over 16 I can take as a common. It's a 63 over 5 plus 1 over 8. Now after the calculation you will get, this is the required answer of this problem. So you can simply scan and join my WhatsApp group for the more detail. I hope you can learn various shortcut tricks in this complete lecture. I hope you can like, share and comment my videos. You can share with your other participants. Thank you very much. Best of luck.